Welcome to Pratidhwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my delight, pleasure, and an honor to welcome a person whom I have, looked up to, learned a lot, and importantly, also he has been a great teacher and a great researcher, uh, Professor Anindya Datta. Anindya Da, whom we call as Anindya Da, has been actually one of the outstanding molecular spectroscopists, and also in recent times molecular spectroscopy combined with microscopy and ultrafast dynamics, and looking into molecules from a time perspective and also spatial perspective. And he and his lab has been working on various interesting problems related to molecular spectroscopy, and in recent times nanomaterial spectroscopy. And he also comes from a very rich background of physical chemistry and spectroscopy, dating all the way back to his college days in Presidency and subsequently in IACS, where he worked with some of the stalwarts, whom we also will discuss a little bit more. With this tiny introduction, let me welcome Anindya to Pratidhwani.
Hi, Pawan. Thank you very much for having me over at Pratidhwani.
Eh,
And thanks for that very kind introduction.
My pleasure. My pleasure. So, Anindya, please tell us a little bit about your growing up years. Where were you born, and what was the kind of background in which you were actually, educated, and your ecosystem and other things, please.
So, all my education has been in Kolkata.
Hmm.
So, I was born in 1970, which was very tumultuous time for the city, the state, and also the country and neighboring regions. So, and I grew up in a joint family. So, we were 30, 35 people staying in the same building. And so, even before school, my learning process started, I believe, at home
Mm-hmm.
because there are different kinds of people. The family had like smaller subfamily units.
Hmm.
And I had this aunt of mine who had this unbelievable collection of Bengali books. As many would know, publishing houses bring out special numbers during Durga Puja.
Hmm.
And a very well known publishing house of your, even now it's there, but uh, is called Dev Sahitya Kutir. Dev
Hmm.
Sahitya Kutir. They used to bring out these hardbound, thick volumes during Durga Puja, which were an absolute delight to read. So I was fortunate enough that my aunt uh, had preserved almost 50 years of those publications.
Wow,
So I got to read
amazing,
all of those. And while
amazing.
reading those as a young boy, I could actually see how the thought process, aspirations, goals of the country evolved over these 5 decades,
Hmm.
starting with maybe 10 years before independence. That was a very unique experience that I had. And I went to St. Joseph's College. That is interesting and amusing because my school was called college. So I've
Hmm.
been in college since my kindergarten. And
Interesting.
there, I was fortunate to get a very cosmopolitan upbringing because we had students who spoke many different languages.
Hmm.
So 40%, 45% of the students were Bengalis, of course, being in Kolkata. But there was a sizable number of Gujaratis, Marwadis, North Indians, small number of South Indians, and what might be surprising for some, uh, maybe 4, 5 Chinese students per class.
Wow.
And this, yeah. So when I say Chinese, I mean people who have been in Calcutta for maybe a couple of hundreds of years.
Hmm. Hmm.
Uh, there is a rich history to that. Calcutta actually has 2 Chinatowns. And my school was in a place which was very close to one. So we had uh, people, students who were well, Chinese, quote
Hmm.
unquote. So that was a very interesting upbringing I had. And we had great teachers in school who nurtured our interest in learning things, not just rote learning, but to understand things. They encouraged us to read a lot. They developed our interest in literature.
Hmm.
So since I'm good at 2 languages only, unfortunately, So we got to read English and Bengali literature significantly. We had a very good library. And then after finishing school, as Pawan, you said, I went to I went to Presidency College, which was another experience at all. Presidency College uh, had fantastic teachers, very good peer group at that time. And my journey towards what I do today was shaped, in fact, even before going to presidency. As I'll narrate a story and a chain of events that I have narrated in many places, so some might know already. So when I was in school, we had a neighbor, and when I say neighbor, I mean a very close family friend, Professor Shamita Basu, who was a PhD student of Professor Mihir Chowdhury.
Wow.
So we used to travel by the same bus for about, say, 15, 20 minutes every day. And before that, there was 15, 20 minutes of waiting for the bus. So for this time, she would talk about what she does and what research is all about. And she'd tell us stories from the lab and all. So I was exposed to this life of a researcher right from high school, say from class 8, class 7 onwards.
Wow. Nice.
And my association with Professor Mihir Chowdhury's academic research family started from that. Then, when I went to Presidency College, the first class in Presidency College was taught by Professor Sanjeev Ghosh. Unfortunately, we lost Professor Ghosh only 2 weeks ago. He succumbed to his disease. He was a phenomenal teacher. And that 1 hour decided for me that I have to become a physical chemist.
Wow. Fantastic.
Not a spectroscopist yet, but a physical chemist. That was an absolutely magical hour. One of the most defining times of my life. He taught us thermodynamics. Later on, he taught spectroscopy and all. But that thermodynamics class built the basics of chemistry for us. And when I say us, I mean the entire class and generations of students who have gone to presidency. There were other great teachers, Professor Parimal Sen, Professor D. Mandal. We learned many different things. We learned from each other. It was, till date, we remain friends, the classmates. I studied MSc in Science College, where again, we encountered many, many great teachers. And that is where, I took up physical chemistry specialization. Even before that, in college itself, Presidency College in those times used to organize seminars every Thursday, where established researchers would come and talk about their research in terms that a first-year BSc student would understand. The first ever seminar I heard was of Professor Mihir Chowdhury.
Wow. Okay.
And he essentially said how lasers work. He brought in those days must have been a Hini laser or something. And he also brought this laser that they had made at that time, nitrogen laser. So it was made of perspex glued together by araldite. And the way he presented it, that seminar sort of decided that I have to become a spectroscopist.
Nice. Nice.
In second year BSc, there was another seminar, this time by Professor Kankan Bhattacharyya, who was a PhD student of Professor Mihir Chowdhury. He talked about surface second harmonic generation, which he had learned as a postdoc in Columbia University and had set it up in as an independent researcher in IACS. Well, from that seminar in my second year BSc, I decided that I have to work with this person. So my life got was sort of decided right there. And then I went to IACS, worked with Professor Bhattacharyya, and then sort of it took off.
Yeah. So I would want to actually, get into some specifics of whatever we just kind of heard from you. First one is that collection of 50 years in India.
Yeah.
That from your aunt. That is a remarkable aspect.
It is.
And I assume that is still preserved. I think, I hope so.
I don't know. I hope so. But I sincerely hope so. If it is not, it'll be a shame.
Yeah. So that is a great, education, to be very frank.
Absolutely.
Right? Because something you not only are absorbing in terms of the specifics aspect of science, but also this much broader education what you're getting from that.
Yes.
Which means that reading must have been a very important kind of habit in your upbringing. Was it so? Was it an important part of your kind of
Indeed, yes. So first of
Mm,
all, I learned the language and how to write and stuff.
mm,
Secondly, I could see how the society has evolved over these years.
mm,
So
mm,
that really shaped my thought process and what I wanted to do. And a lot of what I read there was about not taking things on face value,
mm, mm,
but on questioning everything and reasoning and thinking logically.
mm.
And those became sort of the defining principles of my life.
Wonderful, wonderful, wonderful. Uh, that that bus journey is something which is kind of remarkable. Again, what you mentioned about uh, it is so important for the formative years that you get exposed to somebody who gives you the world view, being a participant, and that person whom you mentioned was actually a researcher. Can you just elaborate a little bit more about her? She's a researcher still, or she's
She
doing?
is now retired.
Okay,
After her PhD, she worked briefly in St. Xavier's College as a lecturer, St.
wonderful.
Xavier's, Calcutta. She's a great teacher.
Hmm.
Then she joined Shaha Institute of Nuclear Physics, which you know, SINP.
Yes, nice.
And she was there all her life until her retirement. Even now, she teaches in many different colleges and universities.
What's her name? If you can mention her
Her
name.
name is Professor Shamita Basu.
Professor Shamita Basu. Nice, nice, very, very nice, very nice. So this actually is remarkable aspect. Also, kind of a little bit of a cultural aspect, right? See,
Yes.
one of the things which I find, at least having discussed and also interacted with so many people who originated from Kolkata, more so generally from Bengal, and in Kolkata itself, the that system of having a high regards towards basic sciences. Chemistry is, of course, it goes back to JC Ghosh, and even before that, of course, PC Ray, and they
Easy.
means, yeah, that actually is kind of an epicenter of so many fantastic things, not only in terms of chemistry, physics, and even JC Bose, if you consider, it expands even beyond physics, chemistry, and in almost even engineering and radio engineering, etc. What is in the air, Anindya? What is that which actually really makes it kind of so attractive for people to really go into basic sciences? I have been asking this many people, and there are some very beautiful answers I've got. I just want to also learn a little bit more from you on what is that aspect in that ecosystem which really brings in more students.
Whatever answer I give would be valid from what I saw, and
Mm, mm,
that journey sort of ended almost 25 years
mm,
ago.
mm,
But I hope that it's the same situation now. I think the very first issue is history.
mm, mm,
Because after all, you mentioned Acharya P.C. Ray,
mm.
him, then Acharya Jagadish Chandra Bose.
Boss, yes,
So these were some of the very first uh, scientists in our country in modern times.
modern times. Yeah.
And they were all in Calcutta. So them being there, that had a profound effect. It was C.V. Raman, in fact,
Mm,
started
mm.
his journey and made his discovery when he was in Calcutta.
Absolutely right. Absolutely.
Because the Meghnad Saha was there. So, and then, of course, not to forget was S.N. Bose and
Price of
others.
boy.
So I think that is the bedrock on which this culture of science was established. That is one thing. Uh, the second issue is that, so this is a positive thing. The
Mm,
perhaps not so positive thing when I was a student was that not many engineering colleges were there.
college. Mm,
Already in other parts of India where already many colleges had come.
mm.
If I remember correctly, there were 7 colleges when I was in class 12
Wow.
in
Okay.
all of West Bengal. So I remember the names now. Now there are many more.
Mm,
So students who are interested in science had many more options in getting a good position, a good college in science than in engineering. That's also another thing. And the third thing is that conventionally, I'll not say that nobody went into business.
mm.
Bengal did have a very rich history of business from time immemorial.
Yep.
Even in more
Yep.
recent times, there were people like Dwarkanath Tagore. and so Rajan Mukherjee and all, who succeeded very much as businessmen. But by and large, the focus was on studying, doing well, getting good degrees, getting a job. So that is perhaps another contributor.
Nice, nice, very nice. It's an important point what you mentioned. So those two lectures, what you mentioned about, one is Professor Mihir Chowdhury, who is actually one of the greatest physical chemists we have had in India, and
Indeed.
followed by Professor Kankan Bhattacharyya, whom I have met and interacted, and I had the privilege of interacting with him. And he is undoubtedly one of the great physical chemists whom we lost, unfortunately, very early. You have had intellectual and also almost close connection with both of them as a student and also as a colleague at some level. I could see how Professor Kankan used to interact with not just people who are senior people who have worked with him, but also even people like me. When I met him a very long time ago, when I was actually he was actually traveling to to some place in the airport, and I had such a long chat with him. I was just starting my career, maybe in 2010. He was the director then of the place there, IACS. And then the kind of interaction we had, I was stunned to really to mention it very without any hesitation, because a person of his stature, you feel that okay, there might be hierarchical kind of viewpoint, but there was none. And he was so nice, so jovial. Again, great sense of humor. Can you just paint a picture of both these great men? I think it's important for us to really keep that them in our memories, so that we get to know.
True. So, Pawan, one aspect that you have already highlighted in what you have said was common for both of them. Both were highly approachable.
Yes.
So that's the first thing. Professor Mihir Chowdhury was already a part of urban legend. He was an urban legend already, part of urban folklore when we were in MSc. Now, what happened in MSc second year was that some of us qualified GATE, and we wanted to look for options where we can go. And Jadavpur was the place to go. If you're in Calcutta, Jadavpur University is there, IICB is there. We went there, and thanks to our naivety, we just walked up to his office and said we wanted to meet him.
Wow. Okay.
Perhaps we didn't realize his stature at that time. But then he actually talked to us for 1.5 hours.
Wow. Nice.
And so essentially it was kind of a career guidance. Interestingly, what he told us, I had violated each and every word of it. Because what he had told me was that don't get into research. There are many good jobs you'll find. Why don't you do that? Then he said, if you do research, don't get into spectroscopy. Material science and biology are very good, so you should do that. And finally, he said, you should not stay in Calcutta anymore. You should try out other places. So I violated all three of these right under his nose. But he did not seem to complain about them later on. So that was one thing. Nice. Same was true with Professor Bhattacharya, Kankan, who, as you said, he would be ready to talk. He would enjoy talking to everybody. And what Kankan enjoyed a lot was to write prescriptions. Yes. So nothing would please him other than somebody approaching him, asking, what should I do in this situation? He loved to guide people on those things.
Absolutely. Absolutely.
Both of them were very, very passionate about their own work. Professor Chowdhury at that stage, when he was nearing 60, already very established and all, I have seen him actually working in the lab. So that is how it was. Same with Kankanda. Yes. Kankanda was very passionate. So, I mean, Kankanda was so intent on working in the lab that I used to go very early to the lab so that I could start before him. Otherwise, if he came in, things actually got late. So, as a student, I wanted to get things going before he would come and start meddling with things. Of course, and there's no need to say that they were very good in their subjects, and that one day, so, teaching in a college is still a very good career option
Mm.
for people in West Bengal. So when we were doing PhD, that is when the College Service Commission ad came out.
Mm.
And Kankanda, before that, asked us a few questions which we could not answer to his content. So he said, "You people don't know anything. Let us discuss."
Mm.
So you walked over to this place where people would usually have tea, but then there was this blackboard there.
Mm.
Word spread and lot of students gathered. And for 1 hour or 2 hours, he discussed fundamentals of physical chemistry.
Mm.
And remember, he was not, at that time, he was not a teacher.
Mm.
He was not teaching regularly.
Mm.
He was a full-time researcher. But then the thing is that is when we understood how good he is without preparation. He discussed everything from thermodynamics, quantum chemistry, statistical mechanics, colloids, solid state, you name it, all of physical chemistry.
Brilliant.
So,
Mm.
and we also realized how great a teacher he is. That we
Mm.
have seen
Mm.
on many, many occasions.
Anyways, yeah.
And another thing I'd say about Kankanda and also about Sir is that he was he's perhaps the most honest person I've seen in my life. He used to say that he would get very angry if you would see any instance of compromise with data quality or any such thing.
Mm. Mm.
So he used to say that we are scientists and the primary duty of the scientist is to speak the truth.
Beautiful.
And
Nice.
that is perhaps the biggest take-home message that I got from him. And both of them would not, so they used to be skeptics.
Mm. Mm.
And I think you agree with me that it is important to be a skeptic if you are in the business of
Business
science.
science. Absolutely. Yeah.
So they would not take anything on face value, no matter
Mm.
how big a person might have said it. They would like to question it and satisfy themselves that this actually makes sense. And these, I
Fantastic.
think, are qualities that any researcher, any student in science must imbibe. Well, it's very easy to give in. When you work in some field, you get some results. It's very easy to say that such and such great person has given this explanation, so I take it. But as you know very well, that science is something that evolves on finding out what was wrong with what seemed to be the right answer yesterday.
Absolutely
So,
correct. Absolutely. So beautifully explained. There's a really an important lesson for all of us in that particular viewpoint. Uh, there is also an element of that curiosity, because even when I spoke to Professor Kankan, and he was also very deeply interested in history of science, because he also used to narrate that beautiful story of Raman, because he was also very deeply associated with IACS,
yes.
and you could see that passion in him about the place. So give us a picture about your own experience and working with Kankanda, and the research problems and research questions you were interested in, because I want to make a transition from them to you, and then go
Yes.
ahead with other things. Yeah.
So when I joined his group, I I'll be lying if I knew exactly what I wanted to do. I
Hmm.
did not. I wanted to do something new. And I joined his group, greatly inspired by that lecture I heard when I was in second year BSc. And I thought I would do surface second harmonic generation. And in fact, I participated in a couple of experiments
Hmm.
in that area. But then the problem is the field had moved already and our equipment could not keep up with it. I'm talking about 1994,
Hmm.
1995.
Hmm.
So that is when the time dissolved spectroscopy at the surface had already kicked in. And we realized that we cannot really do much
Hmm.
unless we get there. And to get there, it would have been a very resource intensive and time intensive. As researchers, we know that it takes time. From the word go to set up a new experiment, it takes such a long time that a PhD student would not be able to do it. So then we transitioned into time resolved spectroscopy. And fortunately, that was the time when there were a couple of lectures in ICS by Professor Biman Bagchi.
Ah.
And he talked about solvation dynamics. And around that time, Professor Graham Fleming, who was then in University of Chicago, moved to Berkeley.
Mm.
He published a few papers. First was on ultrafast solvation in water. Professor Marancelli was also there.
Mm.
And then he published this paper in Faraday on how solvation dynamics slows down in cyclodextrin. And now
Nice.
the thing is, I still go back to Kankan. We did not have a femtosecond laser at that time. So there was no way we could access the ultrafast time domain. But in this one paper, actually it was Kankanda who saw the opportunity of something that we can do with our laser. We had a picosecond laser.
Nice.
And then we got into this business of solvation dynamics. The first work that we did was, interestingly, on solvation dynamics, not in solution, but in a solid media, in a zeolite.
Nice. Nice.
And that was a time when, and my students don't possibly believe me when I tell them this, in IACS, physical chemistry department, the only graph fitting software we had, other than the specialized software for time correlated signal photon counting, the only software that we had could fit straight lines and nothing else.
Okay.
So if you had to deal with an exponential function, you would first linearize it and give it a linear fit. If it was two exponentials, and if you're lucky that they are separated by decades, then you'd get two lines and fit them separately. So we wrote the code on how to make time-resolved emission spectra, how to fit it to log normal functions, and then finally how to. So that is where at that time I was interested in coding. I learned Fortran, and the subroutines were already available, Wellington's book. I wrote the main program, and then I had to go to the computer center to stuff. That is when we got started. So we worked on things like Micels, reverse Micels and all. And then I thought, and then there was a lull, because how many times will you do the same thing? So that is when I proposed that we can look at hydrogels, because there was this very active polymer science unit still there in IACS, and I used to talk to them regularly. So we worked on polyacrylamide hydrogel. Unfortunately, that time we did not get solvation dynamics. They could do it later on, but that was something interesting that we could do. And slowly we moved into more biomimetic systems like liposomes, etc. So what I always wanted to do as a PhD student was try to develop a new angle to what we already see. Then I'll give a very simple example. We try to look at solvation dynamics in reverse Micels, in water pools. And the problem is that the fluorescent probe that we use gets distributed between the water pool and the nonpolar part. And so the signal that you get is actually a mixture of the two. So how to separate those two using our limited computational abilities of that time. Today, it's actually cakewalk. So I could work out a roundabout way of doing it, and that gave me immense pleasure. And that is what something I like to do even now. Try to find ways to solve a problem which is convoluted. Can we separate the components and look at them using techniques that are understandable to us?
Wonderful. Great approach. And actually, it is also a very sensible approach, to be very frank, because it will also, within the framework, what is available, you can then ask many questions. That's a very powerful way of looking at the problem. During this kind of, research, formative years, what were your main learnings, Anindya? What were the kind of broad lessons you extracted out? Of course, you are really doing something very interesting in terms of, ultrafast dynamics related to some problems in solvation and other questions. But there are also some broader lessons you would have learned during this process, if you can share.
So, to give you a sort of one-point answer, what I learned and what I think is very important, I hope you'll agree, for all researchers is I learned to go out of my comfort zone. Because I'm a student of chemistry. I did not really have a training in instrumentation. And here, We had this laser whose electronic component would break down. So to do PhD, I actually had to learn those components. Fortunately, those were days when you could still talk about components, which you could make sense of, and not these complete black boxes that we have today in the form of boards. In boards, I don't know if anybody understands anything. I don't. So they're just, replace kind of service that one can do. But we actually got to work with things like thermistors, capacitors, and all that, so on and so forth. So during PhD, what we learned was it's not just enough to know your core subject. You need to do what it takes. So that can be physics, that can be biology, that can be whatever. It can be electrical repairs, or it can be plumbing. Actually, plumbing was something that we had to do in those days because of the uh, level of sophistication of the lasers that existed at that time. So that is what we learned. That you cannot say no, you cannot say that this is not my job.
Absolutely. Absolutely. That's an important lesson for all the experimentalists and also anybody who would want to actually get into laboratory based research. That's an important thing. So we'll now make a transition of your kind of timeline where you are now finishing your PhD. What were your thoughts? Were there already seeds of you getting into academics? And because I also am very interested in knowing how you became such an excellent teacher, uh, because there would have been a great influence of the people whom you already mentioned. But during that process, did you also think about a future career in
Yeah,
science?
and there was some kind of an overlap, which is not very uncommon in West Bengal those days, but perhaps even now. The thing is, all my life I wanted to be a teacher from maybe high school onwards. So that was my one-track career goal. That's what I wanted to do. I did not really know. I knew about research and how it is done from Shamita Di, but teaching is one thing that I had always wanted to do. So what happened was I told you that this college service commission interview had come. Fortunately, I succeeded there, and I got a job when I was in the final year of PhD.
Wow.
And
Okay.
that opened up another interesting phase of my life for 1.5 years. I taught in Raidighi College. Raidighi is a place which is close to Sundarbans. And it was a new college. It was formed in 1995. I joined in 1997. And when we went to the college, there was no electricity, no running water. There was a tube well. And the floor was not cemented. So it was just sand and bricks laid on top. And hardly any student, unfortunately. So we had only about 4 students in science. There were a good number of students in arts. So my routine was that I'd catch the 6:30, not 6:30, I'd leave Jadavpur at 6:30 a.m., catch a train, get down at a station, get into an auto or a tracks, those big cars, right?
Yeah.
And then travel 21 kilometers from the station and then walk maybe 750 meters or so to reach the college. And then when I got done in the evening, I would retrace my path and go to the lab at about 6:30 p.m. and then work through the night, sleep in the lab. Fortunately, in those days, the director had this nice bathroom, which had a shower, and that was unlocked. So that is where I would get ready. And at 6:30, when the gate of IACS would open, I would walk out instead of walking in. So this went on for 1.5 years. And I think in those 1.5 years, as I said, I was born and brought up in Calcutta. I did not see much of a village except for some tourists But that is where I think I recognized our country. So India lives in villages. The students I talked to or people I saw, what I realized is that they have come through so much of hardship. Primary education is so much less smooth than what I had. I was fortunate to have. So that sort of opened my eyes, and I realized that what is the system that I am in, and what is it that one should realistically expect, and what is it one should strive to improve. So that was my first teaching job, to be honest. And then I went for my postdoc and
Postdoc,
came
yeah.
to Indore.
Yeah. So tell us a little bit about your postdoctoral experience in Iowa. I think you went to Iowa, right? Iowa
Yes,
State University.
Iowa State University. I worked
University
with
and
Professor Jacob Petrich.
Patrick.
And I got it very easy because my senior, Kaustubh Das, unfortunately, we lost Kaustubh a few years ago to cancer. So Kaustubh was already there, and he did some great work with Jake. So that was a time when Kaustubh got a job in Bangalore, and he was coming back. And Jake wanted somebody from the same lab, essentially. So I did not really have to apply to any place. Before applying to the Jake's lab, I sort of got the offer. And there, it was a sea change from what I had been doing in IACS. Because, the way it works there is that you enter the lab, if there's a senior, like also had a month's overlap with me, he sort of taught me the ropes, and then you are on your own.
Yeah, you're right.
And as luck would have it, 2 days after Kaustubh left, our YAG laser died.
Okay.
And that time, see, we worked on an amplified dye laser. So the visible output of the YAG laser would pump the dye laser, output of which would be amplified through 3 stages. And the IR output of the YAG laser would get amplified, frequency double. That was what would amplify the dye laser output. So very complicated setup. And if the YAG laser dies, you understand you're back to square one. Fortunately, there was another YAG laser that we could steal from the next lab, which was closing down. But then, like, all synchronization is gone. Spatial overlap, temporal, everything is destroyed. So I took a few months to get it up and running. And then when it came up, then we did some interesting work. But so that what I learned in Iowa State was to work by myself, because in IACS, we always worked in a group of 2 or 3 or 4. There was, my job was to fix that dye laser. It was minus 25 degrees centigrade outside. And I would work for sometimes 30 hours at a stretch, and then leave the lab at 4 a.m. when there is nobody anywhere, and maybe 2 feet of snow on the road. So that was quite an interesting experience. But I was fortunate to have Jake as my postdoc advisor, because, first of all, I mean, he was very knowledgeable. He thought of problems that are more applicative in nature, and he had complete faith in us. So the way he worked, or still works, is that he assigns you something, then it is your baby. It's your job to go and tell him that this is what's happening and all. And whatever you need within the scope of what can be done, that is made available. So in Jake, I found a great mentor and a friend of unequal age, who's, we are still in touch very much. And that was an important lesson that I learned as a postdoc. And becoming an independent researcher, that journey started from there.
Okay, nice, nice. So were you also been always thinking about coming back? Because with this kind of training,
I was very clear with that. I always wanted to come back. I am an only child. My parents were in India, and so I just wanted to come back and take care of them.
Yeah. So how was the transition? Then you probably moved to Indore, Rajaramana,
That's right.
Center for Advanced Technology, RRCAT, which is very well known for laser physics and many other things. Could you please tell us about that transition? And
yes, and to do that, I'll step back in time by a couple of years once again.
Yeah.
So when I was a PhD student, I attended only 2 conferences outside Calcutta. Even within Calcutta, there were not many, but 2 conferences. The first one in 1997 was in CAT Indore. That time, RR had not been
RR had
added to the name. It was only Center for Advanced Technology.
Yes.
So my first such conference was National Laser Symposium. in 1997 in RRCAT, and that is where I met Dr. P.K. Gupta,
Hmm.
who was head of biomedical application section
Application.
in RRCAT. And even that was a chance meeting because Kankanda asked me to give him some reprints. That's how I went and
Hmm.
walked up and talked to him. And PKG, as we called him, he was a,
Yes.
you
Optical
knew him,
trapping.
right?
Yes, yes,
Yes.
trapping and tweezers. He's a
No,
legend.
he's a very nice man.
Nice,
So
very nice.
So after talking to me for a while, he asked me, "Are you going to present a poster or a talk?" And I had this one of the small contributed 10-minute or 15-minute talks.
Yeah,
He actually came to hear.
nice,
So
nice.
he heard me. And then, see, I had gone to postdoc, taking leave from my college. But
Mm-hmm.
then, so wanted to explore further because if I had stayed in the college, I would not have been able to do research. So, so that was one of the things I did. I wrote to PKG and said, "See, we had met 2 years ago, 2 years ago.
Mm.
And here I am. I'm thinking of going back. Is there anything that I can do in CAT?" And he recognized me. That was remarkable.
Nice, nice.
And then I got this offer of being a visiting scientist in
Mm.
RRCAT. That's what got me back to India. And
Mm.
again, now, when I came back, I told you that my journey of being an independent researcher started as a postdoc
Mm.
researcher. That sort of found completion as visiting scientist in RRCAT. Because I came with the expectation that they would say that we are trying to do fluorescence-based detection of cancer. This is
Mm.
your project, do it. But then what Professor Dr. Gupta told me when we met is that, all right, so you're here, what will you do?
Mm.
Then I said, I mean, what do you mean, what will you do? I thought you are going to tell me to do something. I said, no, you have a PhD, you have 2 years postdoctoral experience, figure out, go around, talk to people. So I had complete free hand.
Nice,
And then
nice.
I did two things. One is I talked to Dr. Alok Dubey, who's still there, I believe.
Mm.
Uh,
Mm.
Alok is a biologist, and he used to work on photodynamic therapy. So we started collaborating with him, and I worked with one of the PDT drugs that they had made out of chlorophyll, spinachidine. And then, in fact, I continued working on that even after I moved
Yeah,
to IIT Bombay.
IIT Bombay.
I worked
Mm.
on many variants. So that was one thing that I did. And the other thing that I did was something that, again, takes me back to when I was in class 8 or class 9.
Mm.
When I attended a science fair in my school, there somebody demonstrated how to detect, well, perhaps very important question on today's date, how to detect dalda in ghee.
Wow, interesting.
Yes. And then what they showed is that it's very simple. All you do is you just add HCl, it turns red if
Right.
dalda is
Yeah.
there.
Yeah.
But
Yeah.
then it turns red not because of dalda. The government requires dalda manufacturers to add a particular molecule to dalda, which
Ah,
would serve as an
sir,
indicator. But
indicator.
then
Nice.
you actually get, I mean, I should not say dalda, vegetable oil, uh, um, without that additive also.
Mm. Mm.
It is available in the market. It's
Mm.
not a, I mean, not brands, but so I befriended Nirmal Ghosh, who
Yes,
is now
Nirmal
in
Ghosh.
IISER Kolkata.
I sir Kolkata. Yes, yes.
Yes. So Nirmal was by that time already an expert in things like light scattering,
Yeah, yeah.
polarization. He had
Polarization.
these. So what we used to see is that he would have like two polarizers, one very cheap detector, and some
Mm.
cloudy water
Yeah.
and cloudy solution, and he would do such fantastic experiments with them.
Experiments. Yeah.
So
Yeah.
Nirmallo and I joined hands, and our routine became that I had a scooter at that time. On Saturdays, we'd go around Indore on my scooter, buying ghee and dalda of different kinds, especially the ones that are not branded.
uh,
And then we'd mix them, record their light scattering. And then Nirmallo would do me theory calculations. So by
yes.
that, the experiment, we could find out this ratiometric parameter, which could tell you how much of dalda is there in ghee. So that was an interesting thing that we could do, thanks to a question that I had when I was a
Mm.
school student.
Mhm.
So I would like to use this platform to tell, in case some student is hearing, innocent questions, naive questions may actually lead you somewhere or the other sometime in your life.
Absolutely. Absolutely. Wonderful. Wonderful. This is fascinating. What a story to also see the trajectory of how things actually get interesting, and
Yes.
it also one of the very fascinating aspect of doing spectroscopy.
Yeah.
That connection between the abstract and the real is so nice.
Yes.
Of course, mediated through a deep knowledge in physical chemistry, quantum chemistry, thermodynamics, etc. Uh, so were you also thinking about establishing your own kind of lab during that time, because you then moved from RRCAT to IIT Bombay? So
Yes.
how did that transition happen, and what was the kind of
So
route?
that was really something that happened without much of an effort.
Hmm.
Because when I was a postdoc, I used to apply wherever I
Yeah.
could, right? And I had already applied to IIT Bombay when I was in the US before coming back. And I got a very enthusiastic response saying, please visit us.
Hmm.
So then, uh, when I was in RRCAT, I got this invitation to come over and present my work. I visited and I had very interesting interaction with who were going to be my future colleagues. I didn't know at that time.
Hmm.
And then I got the job. And that is when I was in a dilemma.
Hmm.
Because I was
Hmm.
already there in RRCAT for 2 years. I was going to become a permanent
Hmm.
scientific officer there. Good thing about being in RRCAT is that you don't really have to worry about funds,
Hmm. Hmm.
provided your
Doing.
project is okay and all.
Hmm.
The difficulty about being there would be that you would not really get students.
Hmm.
That was the time when PhD students were just about being taken in the DA system. And the other problem that we had was that it is an institute with a mandate.
Hmm. Hmm.
So you essentially have to do things that are within that mandate. You cannot really do whatever you want.
What? Yeah.
So that way, and there was not much of teaching. As I said, I always wanted to be a teacher. So that is why when the IIT Bombay job came, I was in a dilemma. I didn't know what to do. Because on one hand, I felt obligated to RRCAT and Dr. Gupta. On the other hand, IIT Bombay,
Hmm.
assistant professor. So I went and in fact, he called me for something else and
Hmm.
he started this very uh, enthusiastic discussion about taking PhD students and stuff. Halfway through, I told him I've got an offer from IIT Bombay. And then there was about 5 minutes of silence.
Hmm.
And then he told me, show me the letter. I went and I took the letter, showed it to him. Then there was perhaps 10 minutes of silence. And after that, and this is the greatness of Dr. Gupta,
Hmm.
after that he said, I would have liked you to stay here for all your life. But this is too good an offer, you have to go.
Wow. Nice. Fantastic. Fantastic.
So that brings out the human quality in him.
Nicely.
And I'm forever indebted to him for
Mm,
having said that. Because had he said once
mm,
that, what are you doing? We invested in you and now you're saying you want to go, I would have said no to IIT Bombay.
mm, mm,
Perhaps that would also have been fine.
mm,
But the very exciting professional life that I've had in IIT Bombay,
mm, mm.
that I would have missed this time.
Missed. Yeah. Fabulous. It's such a nice thing. Sometimes we don't really get to hear these things. It's very very important in India, because that human element is still there. you know
Absolutely.
that's something which unfortunately doesn't really always get projected, because we are in a era where a lot of things actually are just sometimes superficial. There's not much of
Yes.
layering and really asking people of knowing people in slightly greater detail. It's a very fabulous story. Now tell me about that stint. Now you really are getting into IIT Bombay, you
Yeah.
know and fast forward, of course, I need to tell you that you have been not only an excellent researcher there, you've trained excellent students, more than 20 to 22 PhDs or something like that, and so many masters, postdocs, undergraduates. It has become one of the go-to labs across the country if you want to do ultrafast dynamics, spectroscopy, and who have very deep inclination towards even quantum chemistry and questions related to nowadays, even in nanomaterials and even microscopy nowadays, what you have also initiated. Well, this is an important lesson for anybody who is getting in. How did you start? What were your thoughts? Because you have not only been an excellent researcher, teacher, but also have been deeply committed to the institution, where you've taken up administrative positions, including the head of the department, even deanship, associate dean of student affairs, and also in various different capacities you would have served within that institution. So tell us that, Ninja, because that academic life, many people really don't understand that aspect. I want to get a gist of that from you, from
Okay.
your perspective.
So I'll try to respond in maybe 3 or 4 sections.
Yeah.
Because
Yeah.
each of this. So first of all, about training students, the honest confession is that more than me training students, they have trained me.
Mm-hmm.
And I'm talking about research as well as teaching.
Yeah.
And I think you understand what I mean.
Absolutely.
And here I would like to quote a senior colleague of mine. He was convener of physical chemistry when I joined, Professor Manoj Mishra. He used to work on quantum dynamics. So what Professor Mishra told me was, and again, that was sort of an anecdote, when he went to do PhD in Uppsala University, his supervisor told him that you get a PhD the day you teach me something I don't. And that's that. And all these 22 students have actually taught me something or the other that I did not definitely know.
Beautiful.
And all these different directions that our group's research has taken over these years, most of them are actually initiated by the enthusiasm of PhD students. At every stage, I resisted as much as I could because we were already doing something that we liked, but it was the passion of the students that has helped me learn and get into new areas that we have done. That is point number one. And that holds in teaching as well. You have said 3-4 times that I am an excellent teacher. I don't know if I am, but we have course feedback, you also have, I'm sure.
Yes.
So first time I taught a first year course, and teaching first year course in IIT Bombay is scary business. You face the sharpest minds of the country, right? And first couple of times I taught it, the kind of course feedback I got, I felt like I was being flogged in public. But then they were useful because reading through the vitriol that was there in some cases, I could actually figure out what I was doing right and what I was doing wrong, and also what was wrong with what we were teaching. And that part I'll tell you. The problem is that time we were teaching them thermodynamics, kinetics, quantum chemistry. But to prepare for JEE Advanced, already the strategy is learn more than what you're supposed to, so that there can be no unknown. So they felt that we are teaching them something we know already. So that is what helped us to change the curriculum in a way that now what we do is we only teach them quantum chemistry. And we try to answer the questions that a student would get when they would be in class 11 or 12. So we solve the 5-part of Schrodinger equation, for example.
Okay.
So we try and plot the orbitals and show them this is actually what it is. And so on and so forth. We talk a little bit about spin. So now it is one of the most popular courses in the first year.
Nice.
So we could make that transition, first of all, thanks to teamwork. There are lots of people who contributed, Naresh, Arinda, Ruchi, Rajarshi, Sandeep, more recently Ambar, Rahul. and senior people.
Mm.
So BL Tembe
Yes,
was a
yes.
contractor.
Mm. Mm.
So it is because of this teamwork that this course has become something that first year students actually like.
Mm.
Especially in COVID year when we taught it. I mean, somebody came and met us 4 years after that, saying that we still remember in that terrible time, this is what we really liked. So that is one thing, that a teacher actually gets shaped and trained by the students.
Nice.
That is point number one. Point number two is that once again, we started our research using whatever was there. So when I joined, we did not have even time correlated single photon counting. We had one in RSIC using, which used a nitrogen lamp. So full width of maximum of IRF was like 1.3, actually more than that, 2 nanoseconds or something. And it would break down every other day. So to get our fluorescence lifetime data, we'd have to travel to this ultrafast center that had come up in Chennai at that time. Sometimes we went to Indore, who had got an instrument based on the proposal I had written when I was visiting scientist. And we'd go to places like BRC and TIFR, which are closer home. So this way, at that phase, what I learned was that you can only get started if there is active cooperation and collaboration in the scientific community. So I am really grateful to people like Professor Periyasamy, Professor Krishnamurthy, Dr. Deepak Palit, who opened the labs for us.
Nice.
None of them said that we are too busy, don't come. They were busy. All they might have said is that, okay, not this week, come next week. But they let us use our instruments, and that is something that we decided that our lab is going to work like that always. So when we got our time correlated single photon counting, it was a department facility. All day we used to get data for others. Our data would be recorded only in the evening and on weekends and holidays. And of course, sometimes students may not be happy doing this. So what I told them is that this is the price of the instrument. We have not got the instrument. The institute has got it. So this way we started. We started continuing the problem that we had developed in RRCAT. And at the same time, we went back to studying photophysics of molecules. So excited state proton transfer is something that I have been interested in all my life. And there also, interestingly, I collaborated with Professor G.K. Lahidi, who is an inorganic chemist in our department. And so they make these fascinating compounds. Their interest is quite different. So they want to switch spin states and do a lot of things. So I did something very little with them. But then the ligand that we're using in that huge complex, one of the ligands caught my eyes. And I borrowed some from them. And that is, there was 2,2-pyridyl benzimidazole, which undergoes excited state intramolecular proton transfer.
Nice. Nice.
So that got us back into proton transfer. Then from 2 to, it's called 2-PBI, 2,2-pyridyl benzimidazole. Then from 2-PBI, we got interested in 3-PBI and 4-PBI. One summer, I had 3 summer students working on 2, 3, and 4-PBI. They called themselves the PBI family.
Nice.
So this way, and then we started thinking, all right, we have these molecules, we have learned the photophysics. Where can we use them? And the answer also was very clear at that time. We found that these molecules undergo proton transfer only in acidic environments. So if you want to do it at an interface, you need water, you need something that's nonpolar, and you need a negatively charged interface. So on one side, we went into things like liposomes. And on the other, we started working with something called Naphion, which is a polymer, which has a negatively charged interface and which is very useful as a proton conductor in fuel cells. So we were able to learn a few things about Naphion using this fluorescent probe. At this time, we could get into femtosecond because, once again, from the department, we got this FIST grant from DST,
Mm.
and we could buy a femtosecond laser and a femtosecond optical gating spectrometer. That
Nice.
is what got us into the area of fluorogenic molecules.
Mm.
We collaborated with Professor Peter Caruso of Sydney, Australia, with Macquarie University. He, at that time, he had made some, he actually extracted the molecule, which was a protein sensor.
Mm.
It was almost non-fluorescent in water. The moment you bind it with, and it's a covalently bound protein sensor. You add it to protein, it gets covalently bound to the N-terminus or wherever there's an NH2 group, and it fluoresces brightly and in a different color. So that is what got us into this field. And while doing all this, we thought that it would be interesting if we could immobilize these molecules on something and make things like light harvesting devices. That is what got us into silica nanostructures. So we did some work in that. And while doing all this, thanks to the silica work, we got this grant from SARB, which allowed us to get our transient absorption set up. Yes. And the moment we had transient absorption set up, now we were equipped to get into the nano world, look at things like semiconductor nanocrystals. We, at the same time, we had this very enthusiastic student who got us into this different class of fluorogenic molecules based on shift basis. So now we had these different tools by which we could develop a multi-pronged approach to understand what was going on in these systems. So fluorogenic molecules and semiconductor nanocrystals continue to be the two important aspects of what we do now. And then in 2019, we were able to establish the central facility on fluorescence correlation spectroscopy and fluorescence lifetime imaging spectroscopy. And of course, as you know, our association with FCS started thanks to Professor Sudipta Maiti.
I was about to come to that. Yes.
So that is another lab that I visited within a few months of joining IIT Bombay. Still remember, he was having a group meeting. I sort of showed up on, I did not really tell them because those were days before mobile phones. Because I told him, I want to visit your lab. He said, come over. And without saying much, I just went over. So he sort of stopped the group meeting and then he showed me around the lab and all. And then in 2009, we had this fantastic FCS workshop. Yes. Of which you were a part, right?
Yes.
FCS...
No, not the 2009.
Not 2009.
I joined in 2010, IISER Pune. So subsequently, I've been part of.
Subsequently, you became a part. So that was a fantastic thing that happened. Unfortunately, we were not in the instrument building part. So and I think Sudipta has been on your show earlier.
Yes.
What happened was for, I think, 2 weeks, they had this workshop in which 10 groups from around India were shown how to build an FCS instrument. And then they took it back. At the end of it or at the middle of it, there was this big fluorescence symposium that was organized. And I spoke there. I got to know many people. And then that was a Department of Information Technology project, if I remember correctly. So they had to do 3 more workshops anyway after that to see how it is going. So in 2010, we had a workshop in Shillong where I was invited to speak. 2011, it was a bigger workshop in JNU that Shobhan hosted. And then the seed of Fluorescence Society was sown. The project was getting over. The workshop was something that people were already looking forward to. So some of us, initiated by Sudipta, decided that we should do it every year. And it has actually happened almost once every year.
Yes.
Except for COVID time. Another year it was not there.
Even then it was held online in some form.
We did it in 2020. And then the Mihir Hariharan of Trivandrum did it in 2021. That was online. So that is another thing that happened where we learned, first of all, what we do in that workshop, as you know, but for the benefit of those who might be hearing, is that essentially we try to convey to the participants that you should not use an instrument blindly. You must have at least a rudimentary idea of what is going on there. you must have a very good idea of how to do the data analysis, because that is what will tell you something about your system. You cannot just take what comes out and do it.
Do
So
it.
this is
Absolutely.
something that was there. And the other thing that also came out of this was sharing of instruments, right? And that takes us into the third aspect that you had mentioned, administration. Let's leave aside hostels for the moment. If possible, we can come back later. Let me just say what I'm doing now.
Yeah.
As of now, right now, I am the in charge of all the central facilities in IIT Bombay.
Oh, okay. Okay. Yes. Yes.
In fact, a new center has just about been
Terms.
formed, not
Yes.
announced officially. Center for Sophisticated Instruments and Facilities.
Nice.
And I'm the convener of that.
Wonderful.
So what we are trying to do is we're trying to make all the instruments of IIT Bombay open for everybody to use. And since we have this platform, what I would like to request you is, may I share my screen?
Yeah. Please do it. Please do it.
All
No
right.
problem. Yeah. Please do it. Please do it.
So this is, can you see my screen?
Yeah. I can see. No problem.
Okay.
Yeah.
So for people outside IIT Bombay, this is what you need to do. Go to our institute website. Under research and industry, you find this button which says, in very plain and simple terms, use our instruments. If you click it, you are taken to this page where all our central facilities, and some might know that IIT Bombay hosts this sophisticated analytical instrumentation facility, SIFE. All of the instruments are listed. If you want to see all at one go, you click all facilities and you'll get to see everything. But that might be a little overwhelming. So we have classified the instruments into 10 categories that might increase later on. So from here, you can see whatever is there. And then if you click this web page, this is not ready, but let's try and find something that I know. Time resolved fluorescence spectroscopy and microscopy. See, that takes you to the page of the instrument and also to the booking link. So what I'd like to use this platform to convey is that please use this. All these instruments are established by public money. It belongs to no particular person or organization. And I think it is a very important thing for everybody in the country to realize that even if it is something that I've got as my project, of course, for most of the time, it should work to make my problems for which I got the instrument, make that happen. But unless it's a very specialized instrument that you build and all, it should be available for anybody and everybody who wants to use it for at least a fraction of the time. And I'm happy to say that we are doing it in IIT. And wonderful. This is an administrative work, but my involvement with that has also emerged from the philosophy about doing science that has evolved across the years from our experience, from the kindness of other people and interaction with people like the ones we meet in Fluorescence Society who share this common ideology.
Absolutely. Very, very nice. Thank you very much for that particular, demonstration also. And it's very, very useful for a lot of people who would want to utilize this very important facility. I also have to mention that towards the end of the year, there's also an FCS meeting in IIT Bombay.
Yes.
Which Anindya Datta is also one of the main hosts there. In fact, he's the chief person there who is handling the things. So I would urge interested students and researchers also to go.
Yes, by all means.
Yeah, and participate. I'll share the links also in the show note. So, Anindya, please tell us a little bit more before we kind of wind up about the kind of directions you would want to take going forward. What are the kind of things you would want to do? Of course, you are involved in many facets of academic life, but what are the things what you are looking up towards the future? What are the things you would want to actually get into?
So research wise, what we are doing now is that, and see, the thing is, once again, I am sure you also agree with this, is that the life of a researcher is all about trying to find new problems.
Yeah.
We are
Absolutely.
happier to get a new question
Hmm.
than to maybe answer a question that is already known.
No, absolutely
So,
correct. Absolutely.
so what we are trying to do now is that now that we have this fluorogenic molecules and uh, these quantum dots, nanocrystals, now we're trying to think what can you do with them.
Hmm.
And now finally we are perhaps in a position to honor what Professor Mihir Chowdhury had told me at the beginning of my career. The answer is we should get into material science and life sciences.
Like makes sense. The project
So
kind of a gradual progression. Yeah.
very gradual. It's taken decades. So on one side, we are learning with the help of a junior colleague to make devices of these
Hmm.
things, and we feel that both the classes are very promising in this. And while doing this, we are not very good at synthesis of molecules or materials, but sometimes we have beginner's luck, so we have been able to get stuff that look very promising. So devices is one field that we are getting into.
Yes.
The other field that we are getting into is uh, thanks to the effort of a very enthusiastic postdoc and a couple of PhD students. Over the last 1 year, we have learned how to do cell culture
Wow,
and
nice.
how
Hmm.
to handle live cells.
Life sense.
So the idea is with these molecules of ours, or even the nanocrystals, can we target them to particular organelles?
Hmm.
And can we learn a little more about that? And the specific problem in this regard that we have taken up, again, thanks to the interest of the postdoc and the students, is programmed cell death of different kinds. So we
Nice.
have four members of the group working in this direction. And
Hmm.
that also, maybe for the benefit of the students who might be just entering the field, what I'd like to say is that, see, this is what research is about. I've been in the business for several decades. I'm 54 years old, but I feel very young and rejuvenated when I can do something new. It may not be new for the world, it's new for us, right? There are thousands of people who have done cell culture and all. But at the same time, what we try to do is we try to find our own unique contribution to the field
Really.
and try to say something that nobody has said before. That is finally the underlying principle of whatever it is that we
Hmm.
do. And that again takes us back to Professor Kankan Bhattacharyya. This is what he used to say. That was the passion of his life, to say something that nobody has said before for the first time. So that is what we aspire to do. And that is what keeps us going.
Nice.
Not the number of papers, not recognitions, not anything else. It is a very, if I may say, self-serving thing, and
No,
in a
in fact,
positive way.
yeah, in a positive way, because that in that process, first of all, it's actually broadening the horizon of the knowledge boundaries.
Yeah,
And second point is there is a human involvement in this.
true.
Everybody who participates in this actually is gaining not only knowledge, but it's a part of somebody's life,
Yes,
which no metric can capture this. Right, that is an important thing lesson for all of the students, especially and younger colleagues. uh, such an important lesson, Anindya. It's a very very nice thing what you mentioned about. uh, yeah, I wish you and your group all the very best for all the great ventures what you are already into, and also what you have been doing. And also thanks to you for motivating so many people, including me. I look up the FCS gang as somebody who has really motivated a band of people who are interested in doing science in an interesting way, not
true.
shying away from doing instrumentation. And also there's a beautiful community. It's such a nice
Indeed.
yeah, caring community where people are interested in common things. And it's something which has to be fostered going forward. Yeah.
Absolutely.
Yeah. So I thank you very much for the fantastic insights, and also the great visits to the chapters of history of science in their way, which I wanted to capture, especially that ecosystem of physical chemistry in Kolkata. You painted a beautiful picture. Mm. So thank you very much, Anindya. Thanks a lot.
Thank you, Pawan. And let me also say that you are one person who motivates us a lot. We are fascinated by the work you do and by the uh, quiet but intent uh, presence that you bring into the field. So thank you for being who you are.
My pleasure. My pleasure. So this is Pratidwani, where we try to humanize science. This time with the one and the only Anindya Da. Thank you, Anindya. Thank you very much.
Thank you.